This lesson is on the union and intersection of sets. So we've talked previously about sets. A set is basically a collection of elements. They're generally contained within set brackets, like these. So we're going to talk about the intersection of two sets and also the union. So the intersection of sets would be all of the elements that set A and set B have in common. So all of the elements that belong to both set A and set B. So one way to help us to visualize this is the use of a Venn diagram. So in a Venn diagram, within the circle of A will be all of the elements 1, 2, 3, 4, and 5. Within the circle of B, including that middle part, will be all of the elements of 4, 5, 6, 7, and 8. So in the white part of A, I'm going to put all of the elements that are in A but are not in B. So that would be 1 and 2 and 3. But notice 4 and 5 belong to A, so now within the circle of A, I have all of the elements, 1, 2, 3, 4, and 5, but I included 4 and 5, which actually are included in both sets, here in the middle blue part. 6, 7, and 8 belong in B, but don't belong in A, so they should not go in the blue, but they're over here. So this is a Venn diagram that shows all of the elements in set A and in set B, and this middle section that I have colored blue is the intersection of the two sets. So it's all of the elements that the two have in common. So we would say A intersect B equals the set of numbers that include 4 and 5. So the set of 4 and 5 is the intersection of the two sets. The union of sets is all of the elements that belong in either set. So we can use, notice I've used different numbers this time, but I can still put all of the elements they have in common here in the middle, which would be, it looks like 2, 4, and 6. A includes 1, 3, and 5 also, and B includes 8 and 10. Now, if I were looking for the intersection of these sets, that's here, the 2, 4, 6. However, the union of sets is all of the stuff in A plus all of the stuff in B, and make sure you don't count that 2, 4, 6 two times. So if I were finding the union of two sets, which is basically adding the two sets together, A union B would be equal to 1, 2, 3, 4, 5, and 6, and also 8 and 10. So all of the elements that belong in either one of the sets is the union of sets. So notice the U for union, it's kind of like a cup where you just throw everything in. That's how it helps me to remember which one is which. So let's do a couple of practice. I have got A, B, and C, so 3 different sets, and the first question is A union B. So A union B would be all of the elements that are in both A or B. A or B. So I've got A and B and C and D and E and F, and those are all from here. And this has A and C and E, but also has G, I, and K. So this is the union of sets A and B. It's all of the stuff that's in either A or B. Now A intersect B, we'll put down here, A intersect B is just what they have in common. So it looks like they have an A in common, and they have a C in common, and they have an E in common, and the rest of the stuff is not in common. So A intersect B would be just the stuff that would go in the middle, just what they have in common, A, C, and E. A intersect C would be just what A and C have in common. So I'm going to switch colors here. A and C, let's see, A they don't have in common, or B or C or D or E or F. So none of these things they have in common. So the intersection of sets is actually empty. So you can draw it like that. Some people also do this, which means empty set. Typically we do this. If I were to draw my Venn diagram, there would be no overlap of those two circles. It would look like this. There's nothing that those two have in common. Here are a few for you to try on your own. So my first one, I have A union B. Remember, union means all of the stuff that's in one or the other. So this is basically going to be a list of everything that occurs in either one. So R, which comes from A, S, which comes from both of them, T, U, V, W, and that's all of the stuff from A. I've already used S, I've already used V, I've already used W, but now I still have Y and Z. So that is the union of the two sets. It's what belongs in either one of them. For the intersection, it's just what they have in common. So what they have in common would be S and V and W. So my intersection is the set of S and V and W. Last one, we have A intersect C. So I'm looking at this set over here and this set over here. Do they have anything in common? Let's see, X is not in this one, Y is not in this one, and Z is not in this one. So again, this is going to be an empty set. They have nothing in common. Now, all of the questions that we've done so far have been sets that were discrete, and discrete means you can list all of the elements in the set. Now, these are going to be a little bit different because these are called continuous. So continuous means that it's a whole range of numbers. So set A is all of the numbers that are less than 3. And set B is all of the numbers that are greater than or equal to 2. And set C are all of the numbers, that should be a bracket like that, all of the numbers that are greater than or equal to 5. So one way to help us to figure out what the union or intersection of sets are is to put them on a number line. So if I had a number line, let's see, I'm looking at A and B, which is 3 and 2, so say 0, 1, 2, 3, 4, etc. So I'm going to look at what my graph of A would look like, which is all the numbers less than 3, which would be this direction from 3. And this one would be all the numbers greater than or equal to 2, which would be here. So the intersection of sets, not the union, I'm going to go back to that in a second. The intersection of sets, which is 2, is all of the stuff here where both of them would be shaded. Okay, it's where it would be in both Venn diagrams if we drew the Venn diagrams. So that would be including the number 2, because this is a bracket, and then up to but not including 3. So the intersection of sets would be all of the x's such that 2 is less than or equal to x is less than 3. Or if we were writing an interval notation, that would be 2, 3, 2 is closed bracket, and 3 is open. Now that's the intersection. The union of sets, remember, is putting all of the stuff from A and all of the stuff in B from a cup into a cup, and it's whatever is in there. So notice that the whole graph would really be shaded in. If I started all the way at negative infinity, which is down here, all of that's included, all of this is included, some of it included twice, and it continues forever up to positive infinity. So the union of sets would be essentially all real numbers, which we can write like that, or we could say from negative infinity to positive infinity. Looking at A intersect C, again, it might be helpful to draw a number line. So let's do 1, 3, 5, 7. A is all of the numbers less than 3, and C is greater than or equal to 5. So the intersection of sets is where both of them would be shaded. And notice right here in the middle, nothing is shaded. So there's nothing that they have in common. So again, this is going to be an empty set. Now, if it were the union of sets, it would be all of the numbers that were, less than 3, or all of the numbers that were greater than or equal to 5. But they didn't ask us that, they asked us for the intersection. Try this one on your own, same idea. We're dealing with continuous sets now. So A is all of the numbers that are greater than 1. So again, I'm going to draw myself a little number line to help us visualize what's happening. For set A, I've got greater than or equal to 1. So from here, shaded to the right on forever is set A. Set B is less than 4. So that's going to be open, less than 4, shaded this way. The union of sets is anywhere where either one of them would be shaded. So notice, again, I'm dealing with the entire spectrum would be shaded, so that's negative infinity to positive infinity. But the intersection goes from here at 1 to here at 4. It's closed at 1 and open at 4. So if I were doing interval notation, that would be 1, bracket, close bracket 1, comma 4, open bracket, or 1 is less than or equal to x is less than 4. Set builder would include all the x's such that. And then A intersect C, I've got numbers greater than 1. Let's do our number line again. This one's going to be a little bit different. This one is all of the numbers that are greater than or equal to 1. So that's going to look like this. And this is all of the numbers that are greater than or equal to 9. So that's going to look like this. So again, where are they all shaded? Everywhere where it's greater than or equal to 9. Because here, forever, those will both be shaded. So my answer, would be all of the x's such that x is greater than or equal to 9. If we're doing that in interval notation, that would be from 9 on to infinity. Just like that. Last couple for us to try. Here they didn't tell us A is this or B is this, but it's essentially the same idea. So they're giving us 2 sets, and again, if it's helpful for you, you can always draw in the number line. This set goes from negative infinity up to negative 2, 0 to 4, etc. Give us an idea of what's happening. This goes from negative infinity all the way up to negative 2. And this one goes from negative 4 all the way up to 3. So this one keeps going forever. So the union is anywhere where either one of them would be shaded. So obviously this goes on to negative infinity. And all the way up, these are now both shaded, but it doesn't matter, all the way up to 3, but not including 3. So my union of sets would be from negative infinity up to 3, but not including 3. My intersection of sets, where they're both shaded, is just from here to here. So from negative 4 up to 2. 2 is not shaded twice, it's just shaded the once. Oh, sorry, negative 2. Forgot my negative. From negative 4 to negative 2, this one had the bracket, this one had the open bracket. Go ahead and try this last one and then press play. Again, not a bad idea to draw yourself a number line. The first one goes from negative infinity up to negative 5. And my second one goes from negative 7, put 0 over here, from negative 7 over to 0. My union would be anywhere where either one is shaded, so this one all goes to negative infinity. So from negative infinity all the way up to 0, something's going to be shaded. So negative infinity up to 0, open bracket, because this is open. An intersection would be just from here to here. So negative 7 to negative 5, both open brackets.